Hello, welcome to Derivative Rules by Josh Sennett. The first rule I'm going to talk to you about is the power rule. Here's the formula for the power rule. The derivative of any constant times x to the n is equal to that constant times the exponent n times the variable to the n minus 1. A is a constant, and for example, here's a simple problem. Y equals x to the third. The derivative would be 3x to the n minus 1 would be 2. Now for a more difficult one, zoom out a little. This one involves fractions and going into negative exponents. So y equals 12x times 1 over 3. So 12 times 1 over 3, that's the n being brought in front, x to the 1 minus 1 over 3 minus 1 minus 1. So that would be negative 2/3 plus, here's the second term, 3 over 2 times negative 2 over 3 x to the negative 5 over 3 because it's 1 less, plus 0, of course, because 1 is a constant. So your final answer is 4x to the negative 2 over 3 plus, this would just equal negative 1, negative x to the negative 5 over 3. The next rule is the product rule. The product rule, well, this is the formula. It might be kind of hard to read. It's actually really simple. Just think that it's the function of one times the derivative of the other plus the function of the second times the derivative of the first. So, for example, here's your original function a of x, 3x squared plus 6 times 2x minus 1/6. So the derivative would be the first 3x squared plus 6. That'll be our first function, times the derivative of the second. And the derivative here is just 2, because the variable phrase is 2x, plus the second expression, times the derivative of the first. Here we get to use the product rule again. We have 3x squared, so that would be 6x to the 2 minus 1 is just 1. If we multiply out, we have 6x squared plus 12 plus 6x squared minus x. So we have 12x plus 12 minus x. The third rule for derivatives is the quotient rule. Here's the formula at the top. It's kind of an eyeful. It's a lot to read, but it's really simple if you just think of this little catchy phrase, and that's low d high minus high d low over low squared. So, using that, let's just do this pretty simple problem. 3x squared over 1 plus 6x, you're trying to find the derivative. So low d high, take the low expression, which is 1 plus 6x. D high, you're trying to find the derivative of the first expression on the top in the numerator. So you know that would be 6x, because we're using the power rule, plus high, d low, 3x squared. D low would be 6. And then all this is over low squared, 1 plus 6x squared. So multiplying this out, you would get 6x plus 36x squared plus 18x squared over 1 plus 6x squared. that is equal to 54x squared plus 6x over 1 plus 6x squared. Here's your answer. Trig functions are the final rule that we're going to go into, and there are 6 of them because there are 6 trigonometric functions, and what I suggest is for you to memorize all 6 of them. It might take a little bit of time, but I think it's worth it because you'll be able to speed through the AP exam without thinking about it, or you'll be able to go through tests and you won't have to derive them. But I'm also going to derive one of them just to show you how it can be done. The thing is that you need to know that sine x, the derivative is cosine x, and cosine x, the derivative is negative sine x. And then you can derive the rest. So, for cotangent x, we have cosine x over sine x, because that's the definition of cotangent x. The derivative would be, if you're using the quotient rule, because that's what we have right here, a quotient, low d high minus high d low over low squared. So low d high minus high d low over low squared. Now, if you're going to simplify these, you multiply out the negatives. Negative sine squared x minus cosine squared x over sine squared x. And what you might see in the top is that if you factor out the negative 1, you'll have negative 1 times sine squared x plus cosine squared x over sine squared x. And you know that sine squared x plus cosine squared x is just equal to 1. So your answer will be 1 over sine squared x, or negative 1 over sine squared x, or negative cosecant squared x. Here's our final problem. It's just going to be a combination of all 4 last of the 4 derivative rules. And so here we have a quotient, but inside we have trig functions, we have some product rules. Basically, we're going to be using all 4. So let's first define the low function and the high function. A high function we'll use as h of x, because that's pretty self-explanatory. H of x equals sine x times sine x. H prime of x would equal the product rule. We want to do sine x times the derivative of the second, which would be cosine x, and then the same thing, just sine x times cosine x. So h prime of x equals 2 sine x cosine x. These are the same terms. Now for the low, we'll use L of x. That equals 2x to the 5th plus cosine x. To take the derivative, you have the power rule. That would be 10x to the 5 minus 1, which is 4, plus negative sine x. Now, to take the derivative of this function, we just want to do low d high minus high d low over low squared. So low would be, low is here, 2x to the 5th plus cosine x d high times 2 sine x cosine x minus high d low. 10x to the fourth okay, and that's all over low squared. We multiply out these different phrases, and we'll have 4x to the fifth sine x cosine x, just multiplying this, plus 2 sine x cosine squared x minus 10x to the fourth sine squared x. And now we have minus a negative, so it's going to be plus sine cube x. It's all over 2x fifth to the fifth plus cosine x squared. And here's our final answer. And it's kind of long and doesn't really simplify to something nice, but sorry about that. And if you want it upside down, because I think it's upside down right now, here it is the other way.